Hi everyone, Jason from Makera here with another introductory video for getting started with CNC machines. And in this video, we're sharing what CNC machines are, what types of CNC machines are available, and also looking at which CNC machine might be best suited for the projects that you're looking to create. CNC stands for Computer Numerical Control, and this describes a machine which is controlled by a computer based on a coordinate system. CNC machines are not new, and they've actually been around since the 1950s. Early CNC machines were essentially modified traditional machines like mills or turning centers with electric motor control so they could be operated using a numerical system. Even today, modern CNC machines are very similar to the traditional machines that you can still use for a range of projects, but new technology have made modern machines a lot more efficient, more reliable, safer, and even more affordable. Now, there are many different types of CNC machines out there. Common types include 3D printers, laser cutters and engravers, final cutters and plotters, mills, routers, lathes, or turning centers. And there's even more CNC machines available too, like water cutters or plasma cutters or wire EDM machines that are used in industrial settings. But while there are many different types of CNC machines out there, the core operation and the way that these machines move and function and we design for them is typically very similar. All CNC machines move across different axes, with simple cutting machines moving in 2 axes, 3D printers and basic mills and routers operating in 3 axes, and more advanced machines operating in 4, 5, or even 6 axes. To travel across these axes, machines typically use a combination of rails or rods and stepper motors or servo motors to actually travel and move during operation. So what makes these machines really unique is how the machines assemble the types of components that are used, as well as the type of toolhead equipped on the machine. For example, 3D printers are built very similarly to laser cutters or mills, but one has an extruder while the other has some type of spindle or laser module. This is why you can typically find CNC machines that perform a range of operations and tasks, like the Carvera or the Carvera Air, which are mills with laser modules. But what actually makes CNC machines operate? Well, as we now know, all CNC machines move through a coordinate system across different axes. And to do this, they follow a coded file, which tells the machine what coordinates to go to, as well as what to do at each coordinate. This coded file is written in G-code, which actually used to be written manually line by line, which you can still do if you want to. But this isn't practical for more complex projects, as machining something as simple as this puzzle would be thousands of lines of code. So instead, we use CAM software to generate this coded file for us. You may already be familiar with CAD software, which stands for Computer-Aided Design. This is where we can design the models and parts that we want to manufacture using different design tools depending on whether we are making a 2D project or 3D project. CAM stands for Computer-Aided Manufacturing, and this software allows for us to import our CAD designs and prepare them for manufacturing with a CNC machine. For 3D printing, this software is typically called a slicer because it slices a model in layers and generates a G-code file which instructs the 3D printer how to move and make the part layer by layer. For lasers, mills, routers, and turning centers, we use CAM to select different cutting tools as well as set different tool paths and operations for these machines to perform so that the part can be manufactured. The reason that there's different steps for preparing CAD files for one type of CNC machine compared to another is because of what operational methods are at play. 3D printers are considered to be additive manufacturing machines because you start with nothing and material is then added to make your part. Mills, lasers, and many other CNC machines are considered to be reductive or subtractive manufacturing machines because you start with a piece of stock or material and material is then removed to create your part. And while there are many different CAD and CAM programs out there, not all of them are universally compatible with every type of CNC. Some CNC manufacturers require to use their software, while the Carvera and Carvera Air can manufacture projects using a wide range of 2D and 3D files and are compatible with many different CAM programs. When you choose a CNC machine, you should consider the types of projects that you want to create, as well as the types of materials that you want to work with. 3D printers are great at making small, detailed models out of some form of plastic. Lasers can cut and engrave 2D projects rather quickly, while mills can machine a wide range of 2D and 3D parts out of wood, metal, carbon fiber, virtually any material depending on the type of mill that you choose. And as mentioned earlier, CNCs come in many different forms, so choosing one that fits your working environment is also key. key. If you're a beginner, we recommend that you choose a machine that has automatic calibration features like the Carvera and Carvera Air's probing and auto leveling feature, as well as CNC machines with safety features like scan margin and built-in dust collection. And when working in makerspaces, schools, or other type of small working environments, we also recommend that you consider a machine that is fully enclosed, as this will create a safer and cleaner space while also reducing noise. Quality is also very important in order for you to be able to find success with your CNC projects. We build our desktop mills using higher quality parts and assembly systems like rails and closed loop servo motors on the Carvera, or a rigid die-cast frame on the Carvera Air so that you can make incredibly precise projects with ease and repeatability. And to perform these cutting operations that we've been talking about, mills and routers use a wide range of bits to create different types of cuts within a project. You might find yourself needing 2, 3, maybe even 6 different cutting tools to create a complex project, which makes machines that have quick tool changes or an automatic tool changer incredibly helpful. By considering all of these factors, we strive to make our machines more versatile than most by equipping you with incredible tools that allow you to work with a wide range of materials on a variety of projects. And personally, as somebody who's been teaching these concepts for a long time, I can say that the 2 biggest challenges that you're going to face as you start your CNC journey are setup and software. Choose a machine which does a lot of the setup and calibration for you, and one that comes with a lot of documentation, tutorials, and guides. Also choose one that allows you to work with the CAD and CAM software that you want to use. But also be patient, expect to make mistakes, and ask for help. You can check out more introductory videos, how-tos, and guides on the Makera YouTube channel and wiki page. Of course, please don't forget to subscribe, and thank you for watching.